Hello and welcome to another video on mechanics in sport. Today we're going to be having a look at hockey and the role that momentum has to play within the sport. Before going through any examples, it would be wise to start by defining a couple of key terms. The first is, as you would have guessed, momentum, and this is the product of a body's mass and its velocity. Its unit is kilogram meters per second, and it can be written in equation form as P equals m times v, where P is momentum, m is the mass of the body, and v is the velocity of the body. We must now define the law of the conservation of momentum. This is that in a closed system where no external forces are acting, the momentum before a collision is equal to the momentum after a collision. Essentially, all this means is that no momentum is going to be taken away from the system and no momentum is going to be added to it. We now look at our first example in which a player is hitting a stationary ball. We are given the following values. The mass of the stick is 0.5 kilograms, the mass of the ball is 0.15 kilograms, the initial velocity of the stick is 25 meters per second, and the initial velocity of the hockey ball is 0 meters per second as it's at rest. After this collision between the hockey ball and the stick has velocity 20 meters per second, and the ball has velocity v subscript b, and it's our job now to find out what vb is. We begin by calculating the total momentum before the collision. This is the mass of the stick multiplied by the velocity of the stick added to the mass of the ball multiplied by its velocity. In this case, we have 0.5 multiplied by 25 plus 0.15 multiplied by 0, meaning that we have a total momentum before the collision of 12.5 kilogram meters per second. Now that we have this value of 12.5 kilogram meters per second, we can use the law of the conservation of momentum to realise that the momentum after the collision must also be 12.5 kilogram meters per second. Therefore, after the collision, we have the momentum, which is 12.5 kilogram meters per second, is equal to 0.5 times 20 added to 0.15 times the velocity of the ball. Through rearranging the equation, we have 8.5 over 0.15, which is equal to 56.67 meters per second, the final velocity of the ball. We now move on to our second example, in which the ball already has velocity in the same direction in which it's about to be hit. In this case, we're going to try to figure out the velocity of the stick before the collision. The mass of both the hockey ball and the hockey stick remain unchanged, whilst the initial velocity of the hockey ball is now 0.2 meters per second, and the final velocity of the stick is 12 meters per second, and the final velocity of the ball is 40 meters per second. Again, by the law of the conservation of momentum, we know that the momentum before the collision is equal to the momentum after the collision. Therefore, we calculate the momentum as 0.5 times 12 added to 0.15 times 40, which is 6 added to 6, which is equal to 12 kilogram meters per second. In order to calculate the initial velocity of the stick, we set the momentum before the collision equal to 12 kilogram meters per second, which is then equal to 0.5 multiplied by the initial velocity of the stick added to 0.15 times 0.2, which when rearranged gives the velocity of the stick is equal to 12 minus 0.03 all over 0.05, which equals 23.94 meters per second. If you enjoyed this video, be sure to check out the rest of the ones on our channel, and if you have any questions, feel free to leave them in the comments below and I'll make sure to answer them. Thanks for watching, and goodbye.